You are surrounded by an ocean you can never fully see, not because your eyes are weak, not because your instruments are crude, but because the universe itself withholds most of its contents. The shock is not that space is large. The shock is that reality arrives to you only when it is allowed to. Everything else, no matter how real, remains absent by rule, not by chance. The night sky feels open, generous, endless. It invites the illusion that, given time and better tools, you could eventually map it all. Yet that invitation is misleading. What you see is not a complete portrait of existence. It is a carefully constrained sample, a region of reality that has managed to reach you before being stretched away. You live inside a bubble of visibility, and its boundary is drawn by physics, not curiosity. This boundary is subtle. There is no line in the sky where stars suddenly stop, no edge where darkness thickens into a wall. The limit is quieter than that. It is defined by light, by what has had time to travel across space and arrive where you are now. Every point beyond that limit can exist in perfect detail, unfolding its own history, forming stars and planets, perhaps even observers. But if its light cannot reach you, it might as well be invisible forever. In everyday life, distance is an inconvenience. In the cosmos, distance is destiny. Space does not merely separate objects, it controls who can ever know about whom. The universe expands, and as it does, it stretches the pathways along which information travels. Light does not simply cross space, it struggles against a moving stage. Some messages make it through, others never will. This is the cosmic blind spot, not a failure of science, but a feature of reality. When astronomers speak of the observable universe, the phrase sounds temporary, almost apologetic. Observable suggests that more will eventually come into view, but the truth is harsher. Observable does not mean what we have observed so far. It means what is physically capable of affecting us. The distinction matters, because some regions are not just unseen, they are unseeable. You can imagine standing on a calm sea at night, holding a lantern. The light reaches a certain distance, illuminating the water, the waves, the horizon. Beyond that glow, the ocean continues, but without reflection, without feedback. No matter how long you wait, the darkness beyond the lantern does not become visible, not because the sea ends, but because light does. The universe works the same way, except the lantern is time itself. Every photon that reaches you has survived a journey measured not only in distance, but in endurance. Space stretches as light travels through it. Wavelengths lengthen, energy thins, signals weaken. At sufficient distances, the stretching becomes so extreme that light is diluted beyond detectability, not destroyed, just rendered silent. This means the sky is not a live panorama. It is a historical record. You are not watching the universe as it is. You are watching it as it was, layered by distance. Nearby stars are recent memories. Distant galaxies are ancient recollections. The farthest light you can see comes from a time when the universe itself was young, hot, and dense long before Earth existed, long before the sun ignited. Beyond that ancient glow lies a region you can never witness directly, not because it lies too far away in space, but because it lies too far away in causal connection. The universe has an age, and light has a speed. Those two facts alone carve reality into accessible and inaccessible domains. This realization changes the tone of astronomy. The discipline often feels triumphant: new telescopes, deeper surveys, sharper maps. But beneath the progress is an unspoken constraint. No instrument, no matter how advanced, can see past a boundary defined by time and expansion. There is no technology that outruns causality. You can build a bigger mirror, You can cool detectors to near absolute zero. You can launch observatories beyond Earth's atmosphere, beyond its orbit, even beyond the solar system. All of that expands clarity, not reach. The blind spot remains, and it is not static. As the universe expands, that bubble of visibility evolves. Some regions that are observable now will not remain so forever. Their light is already on its way, but future light may never arrive. There are galaxies whose photons are en route to you at this very moment, stretched thinner with each passing second. When the last of that light passes, those galaxies will fade from causal contact entirely. They will not explode or vanish. They will simply become unreachable. This is not science fiction. It is not speculation. It is the mathematics of expansion. Confirmed by observation, the unsettling implication is that the universe can lose information without destroying it. Knowledge is not erased, it is stranded. There is no cosmic archive you can access later to recover what slipped away. Once a region passes beyond the horizon of influence, it becomes part of a reality that cannot touch yours. From inside the bubble, the universe appears finite. From the outside, if such a perspective even makes sense, it may be vast beyond imagination, infinite, perhaps, or finite but incomprehensibly large. The cruel irony is that the difference may be undecidable. If most of reality is permanently hidden, then its true scale may be something you can never confirm, no matter how long you endure. This is where intuition fails. We are accustomed to thinking that ignorance is temporary, that questions persist only until better answers arrive. The cosmic blind spot challenges that assumption. It suggests that some questions are unanswerable not because they are poorly framed, but because the universe does not allow the evidence to reach you. You can test theories. You can model possibilities. You can infer indirectly. But proof requires contact, and contact requires light, time, and a cooperative geometry of space. When those conditions fail, certainty collapses into probability. This does not diminish science. It sharpens it. It forces honesty about limits. It replaces conquest with listening. In a universe that reveals itself only partially, observation becomes a privilege rather than a guarantee. Standing inside this bubble of visibility, you are not at the center of everything. You are at the center of what can reach you. The distinction matters because it transforms the universe from a puzzle to be solved into a relationship to be maintained. The sky above you is not empty. It is filtered, curated by distance, shaped by time, constrained by expansion. What you see is precious precisely because it is not everything. And in that realization, the cosmos feels quieter but more profound. You never see the universe as it is. You see it as it was allowed to be. This is the quiet truth hidden inside every astronomical image. The stars above you do not exist in the present tense. They exist in layers of delay, arranged not by position alone, but by time. Distance in the universe is inseparable from memory. To look far away is not to extend your vision outward. It is to sink backward. Light is the messenger that makes this possible, and also the constraint that makes it unavoidable. Nothing in the universe travels faster. No information outruns it. Every color, every shimmer, every faint glow in the sky arrives late. Some arrive minutes late. Others arrive millions or billions of years late. The universe does not speak to you in real time. It whispers through echoes. When you look at the sun, you see it as it was about 8 minutes ago. That delay feels trivial, almost insulting to call it cosmic, but it establishes the rule. Even the nearest star outside the solar system is already years behind the present. Light from Proxima Centauri takes more than 4 years to reach Earth. If something dramatic happened there tonight, you would remain unaware until long after it was over. Scale that delay outward, and the meaning of the sky changes. The Milky Way becomes a layered structure of different eras. Some stars you see belong to recent history. Others shine from a deeper past. The farther your gaze travels, the older the information becomes. Eventually, distance stops being a measure of space and becomes a measure of age. This is not metaphor. It is mechanics. Light does not cross a static stage. Space itself expands while light is in transit. The universe stretches, and photons are stretched with it. Their wavelengths grow longer. Their energy thins. Their color slides toward red. This process, known as redshift, is not a property of the light source. It is a property of the journey. By the time light from a distant galaxy reaches you, it has been altered by the expansion of everything it passed through. What arrives is not a pristine signal. It is a warn message, shaped by the universe's growth. This is why astronomy is closer to archaeology than surveillance. You are not observing events as they unfold. You are excavating layers of cosmic history, each embedded deeper in time. Telescopes do not function as windows. They function as time machines, limited not by power, but by physics. At extreme distances, the effect becomes profound. You stop seeing galaxies as mature systems. You see them as they were when they were young, smaller, more chaotic, actively forming stars. Push further still, and galaxies dissolve into glowing gas, go deeper, and structure itself disappears. You reach a point where the universe was so hot and dense that light could not travel freely at all. That boundary is not symbolic. It is physical. There was a time when the universe was opaque. Charged particles scattered photons endlessly, trapping light in a dense fog. Only when the universe expanded and cooled enough did light finally decouple from matter and begin its long journey. The faint afterglow of that moment still fills space today, arriving uniformly from every direction. That glow is not distant in space alone. It is distant in time. It comes from a universe less than 400,000 years old, when atoms first formed and darkness finally gave way to transparency. It is the oldest light you can ever receive. Beyond it, there is no image, no direct observation, no photograph waiting to be taken. This is where the idea of looking back reaches its limit. There is a past that light can show you, and a deeper past that remains inaccessible. The universe does not offer infinite replay. It offers a finite archive. What makes this unsettling is how intuitive the sky feels. It looks immediate. The stars feel present. The illusion is powerful because human perception evolved for nearby events, where delays are negligible. On Earth, light is effectively instant. In space, it never is. Once you internalize this, the night sky becomes heavier. Every point of light becomes a survivor of a long journey. Every dark region becomes ambiguous. Is it empty, or merely too distant? Is something absent, or has its message simply not arrived? This ambiguity is permanent. The farther you look, the more compressed history becomes. Billions of years collapse into a single frame. You can witness the youth of the universe, but only in fragments. And as the universe continues to expand, the oldest light becomes increasingly stretched, increasingly faint. Time erodes visibility. There is a quiet cruelty in this. The universe keeps its records, but not in a form guaranteed to remain readable. With enough expansion, even ancient light can be diluted beyond detection. History does not vanish, it fades. This changes how you think about discovery. There is a temptation to imagine that with enough patience, the universe will eventually reveal everything. Light disagrees. It imposes deadlines without announcing them. It sets boundaries that no future technology can cross. The past is not infinitely accessible. It is rationed by the speed of light and the growth of space. Standing beneath the sky, you are surrounded by different versions of the universe, each arriving on its own schedule. Some are recent, some are impossibly old. All of them are incomplete. What you receive is not a full record, but a curated slice of cosmic history shaped by delay. This does not make the universe deceptive. It makes it consistent. Light carries truth, but only within the rules it must obey. It cannot outrun expansion. It cannot compress time. It cannot deliver the present across vast distances. It can only bring you what had enough opportunity to reach you before being stretched too thin. When you look far, you look back, not by choice, but by necessity. The universe has already decided how much of its past you are allowed to see, and the rest remains out of reach, not hidden, not erased, simply too late to arrive. You cannot reach the stars. You cannot touch them, visit them, or place markers beside them. And yet, long before rockets or radio telescopes, humanity found a way to measure how far away they are, not by traveling outward, but by shifting perspective inward. Distance entered astronomy not through conquest, but through geometry. The method is deceptively simple. Move slightly, observe carefully, and notice what changes. Hold out your thumb and close one eye. Then switch eyes. Your thumb appears to jump against the background. That jump is not real movement. It is perspective. This tiny illusion is called parallax, and it became humanity's first ruler for the cosmos. On Earth, parallax is obvious. In the sky, it nearly disappears. To measure stellar parallax, you do not move your head. You let Earth do the moving. As the planet travels around the sun, your viewpoint shifts by millions of kilometers. Nearby stars appear to wobble ever so slightly against the fixed background of more distant stars. The angle is minuscule, often less than a single arcsecond, smaller than what the human eye can resolve. But it is measurable, and from that angle, distance can be calculated. This was not an easy triumph. It took centuries before instruments were precise enough to detect the effect. For generations, astronomers searched for stellar parallax and found none. Some took this as evidence that Earth did not move. Others suspected something more unsettling. Perhaps the stars were far more distant than anyone imagined. That suspicion turned out to be correct. When parallax was finally measured, it did not gently extend the known universe. It detonated it. The stars were not just farther than planets. They were unimaginably farther. The nearest stars lay at distances so great that Earth's entire orbit became a barely perceptible baseline. From this realization came a new unit of distance, the parsec, defined by a parallax angle of 1 arcsecond. It is not an intuitive unit. It exists entirely to accommodate how small those angles are. 1 parsec corresponds to about 3.26 light-years, a distance so large that even light, the fastest messenger in the universe, requires years to cross it. The parsec was a quiet admission. It acknowledged that human scales had failed. The universe demanded its own language. With this new ruler, the stars began to fall into place, not physically, but conceptually. Some were closer. Most were vastly farther. The Milky Way revealed itself as a structure with depth, not a flat shell of lights painted on the sky. Yet parallax had limits. The farther a star lies, the smaller its parallax becomes. Eventually, the wobble shrinks below detectability. Geometry reaches its breaking point. Beyond that, distance must be inferred indirectly. This is where astronomy becomes an exercise in trust. Astronomers began building ladders, chains of methods, where one measurement calibrates the next. Parallax anchored the nearest stars. Certain types of stars were then identified as reliable beacons, objects whose intrinsic brightness could be inferred from observable properties. By comparing how bright they truly are with how dim they appear, distance emerges. Brightness becomes a proxy for remoteness. Light weakens with distance. If you know how luminous something actually is, its faintness becomes a ruler. This technique extended humanity's reach beyond parallax's narrow window. It allowed distances to star clusters, then to neighboring galaxies, then to vast cosmic structures. Each rung depended on the stability of the one below it. If an assumption failed, everything above it wobbled, and yet the ladder held. The deeper this ladder extended, the stranger the universe became. The Milky Way was no longer the whole. It was one island among countless others. Faint smudges, once thought to be nearby clouds, resolved into distant galaxies, each containing billions of stars. The universe was not sparse. It was crowded beyond expectation. But there was a deeper consequence hidden inside this progress. Every method of measurement depended on light. And light, as you now know, carries time with it. When you measure a distant star's brightness, you are not measuring its current state. You are measuring how bright it was when its light began its journey. The farther the object, the older the information. Distance is inseparable from delay. This means the cosmic distance ladder is also a ladder through time. Each step outward moves you deeper into the past. The farther you measure, the less contemporaneous your data becomes. The universe does not present itself as a synchronized system. It presents itself as a layered narrative. There is no master clock to correct for this. You cannot ask a galaxy how bright it is now. You can only receive what it emitted long ago. This creates a subtle tension. Measurements feel precise, numerical, confident, but they are anchored in historical snapshots. The universe you map is not the universe as it is. It is the universe as it was at different moments, stitched together by inference, and beyond a certain distance, even inference breaks down. There comes a point where standard candles become unreliable, where assumptions grow fragile, where the ladder stretches so far that uncertainty compounds. The universe does not yield its scale easily. It allows you to estimate, to model, to approximate, but never to grasp fully. This is not failure. It is honesty, from parallax to brightness, from angles to light years. Humanity has learned to measure the unreachable by embracing indirection. We never touch the stars. We triangulate them. We never stand beside galaxies. We compare their light to expectations built closer to home. Each success expands knowledge. Each method reveals its own boundary, and within those boundaries lies the theme that will repeat throughout this journey. The universe is not hostile to understanding, but it is not obligated to completeness. It permits measurement only where causality allows. Beyond that, distance becomes not just space, but silence. By learning how the first distances were measured, you learn something more unsettling than scale. You learn that knowing the universe has always meant accepting partial access. The stars were never fully reachable, not even conceptually. They were measurable. And that, it turns out, was enough to change everything. For most of human history, the universe had a comfortable shape. It was the sky. It rotated overhead, carried the sun, the moon, and the stars, and returned to the same patterns night after night. Even when distance entered astronomy, the assumption remained intact. All of this belonged to one system, one great starry structure, one cosmic home. That structure had a name, the Milky Way. It was easy to believe, stretching as a pale band across the night sky. The Milky Way looked like a physical feature, a luminous cloud wrapping the heavens. Early astronomers debated its nature, but few doubted its central role. Whatever the universe was, it seemed reasonable that this glowing river of stars was most of it. Even as telescopes improved, the illusion held. Astronomers catalogued faint, fuzzy objects, smudges that refused to sharpen into stars. They were called nebulae, and they appeared to live inside the Milky Way, like distant clouds embedded within a larger structure. The universe, though vast, still felt singular. Then came the question that quietly destabilized everything. What if some of those smudges were not inside the Milky Way at all? Among them was a faint spiral blur in the constellation Andromeda. Through small telescopes, it looked like nothing more than a cloudy patch. It did not scream importance. It did not demand attention. Yet it would eventually redraw the map of reality. The debate simmered for decades. Were these nebulae nearby gas clouds forming stars? Or were they something else entirely, collections of stars so distant that they blurred into mist? The difference was not academic. If they were distant, then the Milky Way was not the universe. It was one object among many. The answer required a new kind of measurement, not parallax, which failed at such distances, but something brighter, more reliable. Astronomers turned to a special class of stars known as Cepheid variables. These stars pulse rhythmically, brightening and dimming in a predictable way. Their pulsation period reveals their true luminosity. Compare that to how bright they appear, and distance follows. When Cepheid variables were identified within Andromeda, the result was unavoidable. The distance was enormous, far beyond the scale of the Milky Way. Andromeda was not a nebula. It was another galaxy, comparable in size to our own, containing billions of stars. The universe did not grow gradually in that moment. It multiplied. The discovery is inseparable from one name, Edwin Hubble. Working in the early 20th century, Hubble used the largest telescope of his time to resolve individual stars in Andromeda. His measurements placed it far outside the Milky Way, shattering the idea that our galaxy was the cosmic whole. The implications were staggering. If Andromeda was a galaxy, then the universe was populated by countless such systems. Each spiral blur in the sky could be another island of stars, separated by unimaginable distances. The Milky Way lost its monopoly on existence. This was not just an expansion of scale, it was a collapse of centrality. Humanity had already endured the realization that Earth was not the center of the solar system. Now it faced something deeper. Even the solar system's host galaxy was not special. It was one among many, drifting in a sea of other galaxies. None privileged by position. The sky changed character overnight. The faintest objects became the most profound. What once looked like imperfections in observation, blurred patches, unresolved glows, were revealed as entire worlds of stars, too distant to resolve individually. Yet, the transformation was not immediately visible to the senses. The night sky did not look different the next evening. Andromeda still appeared as a faint smudge to the naked eye. The shock existed in understanding, not perception. Reality had changed without altering its appearance. This is how the most important revolutions in cosmology tend to happen. Not with explosions or spectacle, but with reinterpretation. The same light, reclassified, becomes something else entirely. With the universe suddenly populated by galaxies, distance took on a new weight. The Milky Way, roughly 100,000 light-years across, was no longer vast. It was modest. Andromeda, larger still, was only a neighbor. Beyond them lay countless others, stretching outward until individual galaxies merged into statistical fields. The word universe had to be redefined. It no longer referred to a single star system. It referred to a population, and this redefinition carried an uncomfortable implication. If galaxies were so numerous and so distant, then light from them arrived heavily delayed. The deeper the universe extended, the more ancient the information became. What you saw was no longer a snapshot of the present, but a mosaic of different epochs. The realization quietly reinforced a theme you have already encountered. Knowledge depends on access, and access depends on light. By the time the Milky Way stopped being the universe, astronomy had crossed a threshold. It had moved from mapping a neighborhood to sampling a population. And with that shift came a new humility. You could no longer hope to catalog everything individually. Statistics replaced familiarity. Patterns replaced places. The universe grew too large to be intimate. Still, the discovery carried a strange comfort. If the Milky Way was not alone, then isolation was not absolute. The cosmos was filled with structure, repetition, and variation. The same physical laws operated across unimaginable distances. Stars lived and died elsewhere just as they did here. Elements forged in distant galaxies mirrored those found on Earth. The universe became less personal, but more coherent. And yet, beneath that coherence lay a quieter consequence. The more galaxies existed, the more of them lay beyond reach. Even as Andromeda entered the map, countless others remained invisible, either too distant, too faint, or already slipping beyond causal connection. When the Milky Way stopped being the universe, reality did not simply expand. It fractured into layers of accessibility. Some galaxies could be studied in detail, others only as points of light, most not at all. You learned that night sky objects were not what they seemed. Smudges became galaxies. Home became local. The universe became plural. And with that pluralization came a lingering unease. If the universe could be so much larger than imagined once, there was no guarantee it would stop expanding in the imagination or in reality there. Before the 20th century, space and time felt dependable. Space was the stage. Time was the clock. Events happened in space and through time. But the two were separate, rigid, and universal. Distance could be crossed in principle. Time ticked the same for everyone. Observation, at least in theory, had no built-in ceiling. Then that certainty dissolved. The shift did not come from a better telescope or a deeper survey. It came from a change in how reality itself was described. With the work of Albert Einstein, space and time stopped behaving like independent backgrounds and merged into a single structure. Space-time was not a passive container. It was dynamic, elastic, and responsive. This altered everything, especially what observation could mean. In space-time, distance is no longer absolute. Time is no longer universal. Motion affects measurement. Gravity is not a force pulling objects across a stage, but a curvature in the stage itself. Matter tells space-time how to bend. Space-time tells matter how to move. The universe becomes less like a machine and more like a fabric under tension. At first, this sounds abstract, but its consequences are concrete. If space-time bends, then paths bend with it. Light does not travel in straight lines because straight no longer exists in the old sense. The shortest route between 2 points is not a line, it is a geodesic, shaped by curvature. This means what you see is not simply where something is, but how space-time has guided its light toward you. Observation becomes conditional. Time dilation makes the effect personal. Clocks moving at different speeds tick differently. Clocks deeper in gravitational wells run slower. This is not philosophical. It is measured daily. Satellites must correct for it to keep navigation systems functional. Time itself flows unevenly depending on motion and gravity. Once you accept this, the idea of a single cosmic now evaporates. There is no universal present moment shared across the universe. Events that are simultaneous for you are not necessarily simultaneous for something far away and moving differently. The universe fractures into overlapping timelines, each valid in its own frame. This matters because observation depends on timing. When you receive light from a distant object, You are not just receiving old information. You are receiving information embedded in a particular space-time context. The order of events can differ depending on perspective. Causality remains intact, but simultaneity does not. The universe stops offering a synchronized story. General relativity extends this further. In a curved space-time, horizons emerge naturally. These are not physical barriers. They are limits of influence. Beyond certain boundaries, events can occur without ever affecting you, no matter how long you wait. Black holes are the most dramatic example. Their event horizons mark regions from which light can never escape. But the principle is broader. Space-time itself can generate horizons on cosmic scales, not because of mass alone, but because of expansion. This is where the limits of observation become fundamental rather than practical. In a Newtonian universe, distance is a challenge. In a relativistic universe, distance can become disconnection, not because space is empty, but because space-time geometry forbids interaction. The realization is subtle. You do not feel horizons. You do not see edges. From your position, the universe appears continuous. Stars shine, galaxies glow. Yet hidden within the geometry is a sorting mechanism that decides which events can ever reach you and which cannot. Observation is no longer a matter of patience or progress. It is a matter of permission. This reframes cosmology. The universe is not just large. It is structured in a way that limits causal access. Some regions are connected to you now. Some were connected in the past, but no longer are. Some will never be connected at all. And no amount of ingenuity changes that. This does not imply ignorance. It implies selectivity. The universe reveals itself through a filter imposed by space-time. What passes through becomes knowledge. What does not remains physically unreachable. Einstein's insight forces humility into measurement. You cannot assume that what you see is representative of what exists. You cannot assume that extension in space implies extension in access. The map is always partial because the terrain is actively shaping what can be mapped. Even the concept of far away loses its simplicity. Far is not just distant. Far can mean delayed, redshifted, diluted, or causally disconnected. Two objects can exist at a fixed distance and yet be separated by an ever-growing gulf of influence. This reshapes the emotional tone of astronomy. The sky is no longer a promise of infinite discovery. It is a negotiation between geometry and information. The beauty of this realization is that it does not reduce wonder. It deepens it. A universe that hides parts of itself is not smaller. It is more intricate. Reality gains layers not only of distance and time, but of accessibility. You begin to see the cosmos not as a place waiting to be explored in full, but as a system with built-in privacy. Some truths are local. Others are global but unreachable. Some histories unfold beyond any observer's horizon, and yet, the laws governing all of this are consistent everywhere. The same equations that limit observation also make prediction possible. The same curvature that hides regions allows stars to shine, planets to orbit, and clocks to tick with measurable precision. Space-time does not deceive. It constrains. By merging space and time into a single fabric, Einstein did more than rewrite gravity. He redefined what it means to know the universe. Observation became relational. Knowledge became conditional. Limits stopped being temporary obstacles and became structural features of reality. Standing beneath the sky after this shift, you are no longer a passive viewer of a cosmic panorama. You are an embedded observer, situated inside a geometry that decides what you can learn. The universe has not grown hostile. It has grown honest, and in that honesty lies a quieter truth. Understanding the cosmos requires accepting that some parts of it will never answer back, not because they are empty or distant, but because space-time itself has decided the terms of the conversation. Distance once felt innocent, a challenge, perhaps, but never a verdict. If something lay far away, it was simply a matter of time before you could reach it, measure it, or at least receive its light. The universe appeared patient. Space was empty, static, and accommodating. That assumption did not survive the 20th century. The universe is not merely large, it is expanding. And that expansion changes the meaning of distance in a way that intuition resists. Space is not a container holding galaxies apart. Space itself is stretching, carrying galaxies with it. They are not fleeing through emptiness. They are being separated by the growth of the stage beneath them. This distinction matters because it transforms distance from inconvenience into destiny. When astronomers first noticed that distant galaxies appeared redder than expected, the implication was subtle but profound. Their light had been stretched, not by motion through space, but by space itself increasing while the light was in transit. The farther a galaxy, the more its light had been altered by the journey. At small scales, this effect is gentle. Nearby galaxies remain within reach. Their light arrives with manageable delay. Their signals are strong enough to study in detail. The universe feels connected, but expansion does not stop at convenience. As distances grow, the stretching becomes severe. Light loses energy. Wavelengths lengthen. Photons arrive thinned and weakened. At some point, signals are no longer merely delayed. They are diluted beyond usefulness. This is where distance becomes disconnection. The expansion of the universe is not uniform in consequence. It does not tear galaxies apart internally. Gravity holds stars, planets, and clusters together. But beyond those gravitational bonds, expansion dominates. Large-scale structure drifts away from itself. You can imagine dots on the surface of an inflating balloon. The dots do not move on the surface. The surface grows between them. From any single dot's perspective, all others recede. The farther they are, the faster they appear to move away. The universe behaves in much the same way, but with one crucial addition. Light has a speed limit. As space expands, there comes a threshold where the rate of separation exceeds the ability of light to bridge the gap. This does not mean galaxies are moving faster than light in the usual sense. It means the space between you and them is growing so rapidly that their light can no longer make progress toward you. Their messages stall. This is not dramatic. There is no moment of rupture, no flash-marking disconnection. Light simply fails to arrive. The universe does not announce its losses. It absorbs them quietly. What makes this unsettling is how normal everything looks from within. The sky does not signal that it is losing access to regions of itself. Galaxies fade gradually. Their spectra slide redward. Eventually, they vanish into wavelengths too long to detect. The universe does not empty. It becomes inaccessible. This changes how you think about the future of observation. Progress in astronomy often feels cumulative. More time, more data, more understanding. Expansion breaks that pattern. Some knowledge has an expiration date. Some information must be received before it is stretched into silence. This does not mean the universe is collapsing into darkness. It means connection is conditional. The cosmos sorts its contents into regions of influence and regions beyond reach, not through violence, but through geometry. Distance is no longer just how far away something is. It is how long it can remain part of your reality. There are galaxies visible now whose future light will never arrive. You are receiving their final messages, not because they will stop shining, but because the expanding universe will eventually prevent any further exchange. This reframes the act of observation. To look outward is not just to learn, it is to catch what is still able to reach you. Every image becomes a rescue of information before separation completes. The idea is emotionally counterintuitive. Expansion sounds benign, even generous. Space increasing suggests more room, more possibility. But on cosmic scales, expansion isolates. It pulls regions apart faster than communication can keep up. You are not watching a universe that is slowly revealing itself. You are watching a universe that is quietly sorting itself into solitude. The speed of this process is governed by the universe's energy content. Expansion accelerates. The farther away something is, the faster it recedes. This acceleration ensures that disconnection is not a distant concern. It is already underway. Yet from your position, nothing feels urgent. Stars still shine. Galaxies still glow. The sky feels stable. That stability is deceptive. The changes occur on scales too large for immediate perception. This is how cosmic processes operate, not with alarms, but with inevitability. Expansion does not care about observers. It does not pause for curiosity. It does not preserve information for later retrieval. It simply unfolds according to the structure of space-time. Once distance crosses a certain threshold, return is impossible, not because travel is hard, but because causality no longer allows interaction. Even hypothetical signals sent at light speed cannot overcome the growing gulf. This is the final transformation of distance. It becomes a one-way filter. Some regions remain causally connected. Others drift into permanent silence. The unsettling conclusion is that isolation does not require emptiness. The universe can be rich, structured, and full of activity yet inaccessible. Vast regions may exist, evolve, and persist without ever touching your awareness. Standing inside an expanding universe, you are not at the center of everything. You are at the center of what has not yet slipped away. Distance used to mean far. Now it means fleeting, and the universe continues to expand, not as an act of destruction, but as a quiet reorganization, one that turns separation into a fundamental feature of reality. The universe does not announce its boundaries. There are no fences in the sky, no warning lights at the edge of visibility. And yet, limits exist. They are not made of matter. They are made of time, speed, and the geometry of space-time itself. These limits define what can ever reach you and what never will. To understand them, you must let go of the idea that the universe has a single edge. Instead, it has horizons. The first is called the particle horizon. Despite the name, it has nothing to do with particles in the everyday sense. It marks the farthest distance from which light has had enough time to reach you since the beginning of the universe. It is not an edge in space. It is an edge in history. Because the universe has a finite age, light has only had a finite amount of time to travel. Even moving at the maximum speed allowed by physics, it can cover only so much ground. Everything beyond that distance exists outside your causal past. Its light has not arrived. Not yet. Perhaps not ever. This means the observable universe is not a snapshot of everything that exists now. It is a cross-section of everything that has managed to communicate with you so far. The particle horizon is the boundary of that communication. What makes this counterintuitive is that the universe is older in every direction. No matter where you look, you are peering into deep time. Yet there is a limit to how far back and how far out that view extends. The particle horizon is not a place you can point to. It is a condition that shapes every observation. Inside that horizon lies all the light you have ever received. Outside it lies everything that has never had the chance. At first glance, this sounds temporary. As time passes, light from more distant regions should eventually arrive. The particle horizon should expand, and it does, slowly. But the universe complicates this picture. Because space itself is expanding, the ground light must cross is not fixed. The finish line moves. Some regions that were once approaching your horizon may never cross it. The universe's growth stretches the distance faster than light can reduce it. This brings you to the second, more unsettling boundary, the event horizon. The event horizon is not about what has already reached you. It is about whatever can. It marks the farthest distance from which light emitted now, or at any future time, will be able to reach you. This is not a historical boundary. It is a destiny boundary. There are regions of the universe whose light you are receiving today, but whose future light will never arrive. You are already seeing the last messages they will ever send, not because they will go dark, but because the universe will eventually pull them away faster than light can keep up. The particle horizon looks backward. The event horizon looks forward. Together, they carve reality into 3 zones. What has reached you? What may reach you? And what never will? None of these zones feel dramatic from the inside. There is no moment when a galaxy crosses the event horizon and disappears in a flash. It simply fades. Its light stretches longer, weaker, redder. Eventually, it drifts beyond detection. The loss is gradual and silent. This silence is misleading. It suggests emptiness where there is only inaccessibility. The universe beyond the event horizon does not cease to exist. It continues evolving, forming stars, collapsing clouds, perhaps even developing observers of its own. But causality no longer connects those events to you. They unfold in parallel, not in contact. This is the deepest implication of horizons. Reality can be real without being relational. In everyday life, existence and influence are tightly linked. If something exists near you, it can affect you. In cosmology, that link breaks. Something can exist fully and forever, yet never intersect your causal world line. The universe allows isolation at the level of entire regions. What makes this especially unsettling is that horizons are observer-dependent. There is no universal boundary shared by all observers. Every location in the universe has its own horizons, shaped by its history and motion. What is unreachable to you may be reachable to someone else elsewhere. Reality fragments into overlapping domains of access. This is not philosophical speculation. It is a direct consequence of general relativity applied to an expanding universe. Horizons emerge naturally from the equations. They are not optional features. They are structural. The analogy to black holes is tempting, but incomplete. A black hole's event horizon forms due to extreme gravity. The cosmic event horizon forms due to expansion. In both cases, information loss is not about destruction, but about disconnection. Light still exists. It just cannot escape or cannot arrive. The key difference is scale. Black hole horizons are local and dramatic. Cosmic horizons are vast and subtle. They do not bend light sharply. They stretch it gently until it no longer matters. This gentleness is why horizons are easy to ignore. The sky does not look truncated. The universe does not appear incomplete. From within the bubble of visibility, everything seems continuous. The illusion of wholeness persists. But the geometry tells a different story. The universe is not offering you its full contents. It is offering you what lies within reach of your past and your future light cones. Everything else exists outside your conversation with reality. This redefines what it means to draw the edge of reality. The edge is not where things stop. It is where influence stops, where information fails, where causality yields to separation. Once you accept this, the cosmos takes on a quieter tone. Discovery becomes finite not because curiosity ends, but because access does. Knowledge becomes local, not universal. Observation becomes an act constrained by geometry. You do not live in the whole universe. You live in the portion that has not yet slipped beyond your horizons, and those horizons are not fixed landmarks. They are dynamic, evolving with time, shaping what remains visible and what fades into permanent silence. The edge of reality is not somewhere out there. It is already woven into the structure of how you see. Time is supposed to give you more. More experience, more memory, more understanding. In science, time is often treated as an ally. The longer you observe, the more you learn. But on the largest scales, the universe behaves differently. Time does not accumulate knowledge. It erodes access. This is the paradox. As the universe grows older, the amount of the universe you can know shrinks. At first, this feels wrong. With better instruments and longer observation campaigns, astronomy has expanded rapidly. Each decade has revealed new classes of objects, deeper surveys, sharper maps. It is tempting to assume this trend continues indefinitely, that the universe is an archive you can keep opening, page by page. Given enough patience, but expansion changes the rules. As space stretches, information thins. Light traveling across an expanding universe does not merely take longer to arrive. It arrives altered, its energy reduced, its wavelength stretched. What once carried rich detail becomes increasingly impoverished, not destroyed, not corrupted, just weakened. Information fades without ever being erased. This fading is not uniform. Nearby regions remain readable. Their light reaches you with strength to spare. Distant regions suffer more. Their signals are diluted by every increment of expansion they traverse. Eventually, there comes a point where light still arrives, but no longer carries usable information. It is present, but mute. Time does not bring clarity here. It brings loss. This is why the future sky will not resemble the present one. It will not be richer. It will be poorer. Galaxies that are visible now will become harder to detect. Their light will slide out of the optical spectrum, then out of the infrared, and eventually beyond any practical means of observation. The universe will not darken abruptly. It will fade selectively. What makes this unsettling is that nothing catastrophic needs to happen. No explosions, no collapse, no cosmic accident. Expansion alone is sufficient. The geometry of space-time quietly filters information until only local remnants remain. The universe becomes simpler not because it has less structure, but because you can access less of it. This runs counter to human intuition. On Earth, time reveals history. Archaeology benefits from patience. Records accumulate. In the cosmos, time buries history under distance. There is no guarantee that waiting will uncover more. In some cases, waiting guarantees the opposite. Information has a horizon, just like light. Consider a distant galaxy whose light reaches you today. That light left when the universe was younger, denser, more compact. You receive it now only because conditions allowed the journey to complete. But light emitted by that same galaxy tomorrow may never arrive. The universe expands too fast. The path lengthens faster than light can traverse it. You are already living in a moment of maximum access. This does not feel dramatic because the loss is staggered. One galaxy at a time. One wavelength band at a time. One bit of information stretched beyond usefulness at a time. The process has no sound, no signal, no announcement. It simply proceeds. The universe does not keep backups. From within, the illusion of continuity persists. You still see stars. You still see galaxies. But the cosmic census quietly diminishes. The sky becomes increasingly local. Structure retreats into gravitationally bound islands, cut off from the wider cosmos. This is the long-term fate of observation. Not ignorance, but isolation. What remains visible does not represent the whole. It represents what happened to stay close enough, dense enough, bound enough to resist expansion. The rest becomes irrelevant not by choice, but by physics. The paradox deepens when you consider memory. Astronomical observations are records. Images, spectra, catalogues, they preserve what once arrived. In that sense, knowledge survives, even as access fades. But those records are finite. They depend on what reached you in time. No future observer can recover what never arrived. There is no telescope powerful enough to resurrect light that expansion has diluted beyond detection. There is no method to reconstruct signals that never completed the journey. Information that fails to arrive is not lost in transit. It never enters your history. This reframes the idea of progress. Scientific advancement is not a straight line outward. It is a race against cosmic dilution. Every observation captures a slice of the universe before it slips further away. The present era is unusually generous. The sky still offers deep views. The afterglow of the early universe is still detectable. Distant galaxies still announce themselves with measurable light. This will not always be the case. Time, in this context, is not a gift. It is a narrowing funnel. This does not diminish the value of discovery. It intensifies it. Every photon received is a survivor of cosmic stretching. Every spectrum is a fragile message that could easily have been lost to expansion. Understanding this changes the emotional tone of astronomy. The universe is no longer a static museum waiting to be explored at leisure. It is a dynamic system where access decays. Observation becomes an act of preservation. The paradox, more time. Less universe forces a redefinition of what knowledge means. Knowing the cosmos does not mean cataloging everything that exists. It means understanding what you can reach, and recognizing that reach is temporary. This recognition is not pessimistic. It is clarifying. It replaces the fantasy of total comprehension with the reality of partial access. It encourages care, precision, and humility. You are not late to the universe, but you are not infinitely early either. The information available to you is shaped by timing as much as by technology. The universe opens windows and closes them without regard for curiosity. What you see now is not guaranteed to remain visible. What you do not see now may never arrive. Time passes, space stretches, information thins, and the universe, still vast and active beyond your reach, quietly becomes smaller, not in existence, but in what it allows you to know. Every map lies, but some lies are useful. This is not cynicism. It is survival. A map that tried to include everything would be unreadable, so it selects, simplifies, and assumes. Cosmology does the same, only the terrain is reality itself. You never see the universe whole, you assemble it. What you call the universe is a construction built from fragments of light that happen to arrive, interpreted through models that assume consistency beyond what can be checked. This does not make cosmology fragile. It makes it careful. The trust you place in cosmic maps is earned not by completeness, but by coherence. The process begins with light, always light. Photons arrive from different distances, different epochs, different conditions. They carry clues in their colors, their intensities, their distortions. No single observation tells you much. Meaning emerges only when many observations are combined. This is where the map begins to take shape. Astronomers survey the sky in patches, then stitch those patches together. They catalogue galaxies by brightness, color, and motion. They infer distances using ladders of calibration. They model unseen matter through its gravitational effects. They smooth over gaps with statistical expectations. The result is not a photograph, it is a synthesis, and synthesis requires assumptions. One of the most important is the idea that the universe is broadly the same everywhere, not identical in detail, but governed by the same laws. This assumption allows you to generalize from what you see nearby to what you infer far away. Without it, the map collapses into local anecdotes. This principle has worked remarkably well. The same physics that explains stars here explains stars billions of light years away. The same spectral fingerprints repeat across cosmic time. The universe appears consistent enough to trust patterns, but trust is not certainty. Every cosmic map is built from a biased sample. You observe what is bright enough, close enough, and cooperative enough to reveal itself. Dark regions remain underrepresented. Faint structures vanish into noise. Entire populations of objects may exist beyond detection thresholds. Absence does not mean non-existence. It means insufficient signal to compensate. Cosmology leans heavily on statistics. Instead of counting every galaxy, you sample and extrapolate. You assume that what you see is representative. You correct for known biases. You test models against independent datasets. Agreement builds confidence. Disagreement exposes fragility. This is why tensions matter. When different methods of measuring the universe yield different answers, it is not merely a technical nuisance. It challenges the assumptions underlying the map. Are the ladders calibrated correctly? Are the samples biased? Or is the universe itself behaving in ways not yet accounted for? Mapping an incomplete cosmos requires constant self-skepticism. The maps you trust most are those that survive multiple lines of evidence. When independent measurements converge, confidence grows. When they diverge, caution deepens. The universe does not guarantee consistency at every scale. It only guarantees that any inconsistency is meaningful. There is also the problem of resolution. On the largest scales, details blur. You cannot track individual galaxies across the entire observable universe. You trace patterns instead: filaments, voids, clusters. The universe becomes a texture rather than a collection of objects. This texture is informative. It reveals how matter flows, how gravity sculpts structure, how small fluctuations grow into cosmic architecture. But it also hides individuality. The map trades detail for scope. Closer in, the trade reverses. You gain detail, lose context. The universe is always incomplete in one dimension or another. This incompleteness is not a flaw of method. It is imposed by horizons. Some regions never contribute data. Others contribute data only briefly. The map you build is shaped by what was reachable during a finite window of cosmic history. Once you accept this, the idea of a final, definitive map dissolves. There is no end point where the universe stands fully revealed. There is only an evolving representation, updated as new light arrives and old assumptions are revised. Trust, then, becomes conditional. You trust the map because it works, not because it is whole. This trust is reinforced by predictive success. Models built from incomplete data still predict phenomena accurately. They explain why galaxies rotate the way they do, why light bends around massive objects, why the universe's large-scale structure looks the way it does. Incompleteness does not prevent reliability, but reliability is not omniscience. The danger lies in forgetting the limits. Maps invite confidence. Lines feel authoritative. Colors suggest coverage. It becomes easy to mistake representation for territory, to forget that beyond the edges of the map lies not emptiness, but uncertainty. The universe you trust is the universe you can test. Beyond that lies conjecture. This does not diminish the achievement. It clarifies it. Building a coherent picture of the cosmos from partial information is one of humanity's greatest intellectual feats. It requires discipline, restraint, and the willingness to revise deeply held beliefs. Every generation inherits a map and redraws it slightly. Some regions gain clarity, others recede. The outline shifts, not because reality changes, but because access does. What you call the universe is therefore a relationship, a negotiated understanding between what exists and what can be known. It is stable enough to guide thought, fragile enough to demand humility. In this sense, cosmology is less about discovering a finished picture and more about maintaining a working one. A picture that acknowledges its blind spots. A picture that earns trust through consistency, not completeness. You live inside an incomplete cosmos. You navigate it with incomplete maps. And yet, those maps are good enough to reveal something profound, not the totality of existence, but the structure of what can be known. That is the universe you trust, not because it is whole, but because it is honest about its limits. A good map does not fail loudly. It fails quietly, in places where lines do not quite meet, where distances disagree, where patterns refuse to align. Cosmology is no different. Its confidence is built on consistency, and its progress begins when that consistency fractures. These fractures are not mistakes. They are signals. You assemble the universe from independent measurements, distances inferred from light, motions traced through spectra, structures revealed by statistics. When these pieces agree, the picture feels stable. When they do not, the discomfort is immediate. Something is wrong, not necessarily with the universe, but with how it is being measured, modeled, or assumed. One of the most unsettling features of modern cosmology is that its most precise tools do not always agree with one another. The disagreement is not dramatic in magnitude. It is subtle. A few percent here, a small offset there, yet the implications are enormous. This is how cracks begin. A map that nearly fits everywhere is more disturbing than one that obviously fails. Obvious errors can be fixed. Subtle tensions linger. They demand attention without offering easy resolution. In cosmology, such tensions often emerge when the universe is measured using different eras. One method looks at the universe's earliest light, preserved from a time when matter and radiation first parted ways. Another measures the universe much later, using galaxies and exploding stars as mile markers. Both approaches are precise. Both are well tested, and sometimes they disagree. The disagreement is not about interpretation. It is about numbers. When the early universe predicts how fast expansion should be today, and the late universe insists it is faster than expected, the gap cannot be ignored. This is not a failure of instrumentation. It is a challenge to the underlying story that connects the past to the present. You can try to smooth over the crack. Perhaps one method has an unseen bias. Perhaps dust interferes with measurements. Perhaps a calibration step is slightly off. These are reasonable possibilities. They are examined carefully, repeatedly, and publicly. Yet the tension persists. This persistence is what makes the data uncomfortable. It refuses to settle into the map you trust. It does not scream revolution. It whispers doubt. Cosmology has faced this before. In the past, anomalies have signaled missing ingredients. Unseen matter, unaccounted forces, new physics hiding beneath old assumptions. But anomalies have also evaporated under scrutiny, revealing themselves as statistical flukes or misunderstood systematics. The difficulty is knowing which you are facing. Another class of cracks appears in the sky itself. Large-scale features that seem too large, too cold, too aligned. Patterns that appear once and never again. Regions where the universe looks slightly different from what uniformity predicts. These anomalies are not dramatic enough to overthrow models on their own, but they resist easy dismissal. They sit at the edges of significance, daring you to decide whether they are accidents or hints. This is the uncomfortable zone of science, the place where data is neither clearly wrong nor clearly revolutionary. Maps are most vulnerable here, because cosmological models rely on assumptions of uniformity and randomness at large scales. Deviations challenge those assumptions. Are they genuine features of the universe, or artifacts of limited sampling? Are they telling you something profound, or simply reminding you that one universe is a small statistical sample? You cannot rerun the cosmos. You cannot average over many universes. You work with what you have. This limitation amplifies the meaning of anomalies. In laboratory science, outliers can be tested repeatedly. In cosmology, you often get one chance, one sky, one history, one realization. This makes interpretation fragile. The temptation is to either overreact or underreact, to declare new physics prematurely, or to dismiss discomfort until it fades. Neither approach is satisfying. Progress lives in the tension between caution and curiosity. What matters is how the map responds. A trustworthy map does not hide its cracks. It highlights them. It invites scrutiny. It encourages independent checks. It resists the urge to smooth disagreement into false harmony. In this sense, discomfort is productive. It forces the community to examine assumptions that were once taken for granted. It encourages creativity without abandoning rigor. It keeps cosmology honest, but honesty has an emotional cost. It means accepting that the universe may not be as tidy as the models suggest, that the story connecting its earliest moments to its current structure may contain missing chapters. That precision does not guarantee completeness. It also means accepting that some cracks may never close, not because science fails, but because access is limited. Some anomalies may reflect features of the universe that lie partly beyond observational reach. They may be shadows cast by regions or processes you cannot fully sample. This returns you to the theme of the blind spot. Maps crack most where data thins, where horizons loom, where inference stretches farther than observation. The universe does not contradict itself out of malice. It contradicts expectations when those expectations outrun evidence. Living with this tension is part of understanding the cosmos. It requires patience, humility, and the willingness to revise even successful frameworks. The history of science suggests that some cracks will widen into revolutions, others will quietly seal themselves. You cannot know which in advance. All you can do is measure carefully, question relentlessly, and resist the comfort of premature certainty. In the meantime, the map remains useful. It guides exploration. It predicts phenomena. It connects disparate observations into a coherent whole. Its cracks do not invalidate it. They define its frontier. A flawless map would be suspicious. It would suggest either perfection or ignorance. A cracked map acknowledges complexity. The universe you inhabit is not obligated to conform to elegant expectations. It offers patterns, not promises. When data resists alignment, it is not an insult. It is an invitation to look closer, think deeper, and remember that understanding is always provisional. The cracks in the map are not failures of knowledge. They are where knowledge is still alive. There is a force shaping the future of the universe that you cannot see, cannot touch, and still do not truly understand. It does not glow. It does not clump. It does not announce itself with violence or spectacle, and yet it quietly determines how much of reality you will ever be allowed to know. This force is called dark energy, and its most profound effect is not expansion itself, but isolation. At first, expansion sounded manageable. Galaxies drifted apart, but gravity held local structures together. The universe grew larger, but still felt connected. Then something unexpected emerged from the data. Expansion was not slowing down. It was speeding up. The universe was accelerating. This discovery was not anticipated. It arrived as a shock, not a confirmation. When astronomers measured the brightness of distant exploding stars to trace cosmic expansion, the The results refused to match expectations. Faraway galaxies were farther than they should have been. The universe was not coasting outward. It was being pushed. That push required a name. Dark energy became the placeholder, a label for whatever was driving the acceleration. It explained the observations without explaining itself, and in doing so, it introduced a new kind of cosmic destiny. Acceleration changes everything. In a decelerating universe, distance is challenging but negotiable. Light emitted far away may take an enormous time to arrive, but patience is rewarded. In an accelerating universe, patience fails. Space stretches faster tomorrow than it does today. The gap widens faster than light can close it. Dark energy turns separation into permanence. This is the engine behind cosmic isolation. Not a sudden event, but a long-term trend. As dark energy dominates the universe's energy budget, expansion accelerates, and horizons tighten. More regions drift beyond reach. Fewer signals arrive. The universe becomes quieter, not because it empties, but because connection collapses. What makes dark energy unsettling is how passive it feels. It does not behave like a force in the familiar sense. It does not pull or push objects directly. It alters the geometry of space-time itself, causing space to expand more rapidly as time goes on. The effect is global, uniform, relentless. From inside, it is almost impossible to notice. Galaxies do not appear to rush away dramatically. The night sky does not change from year to year. Expansion operates on scales far larger than daily experience. But over cosmic time, its consequences accumulate. Eventually, gravitationally unbound structures slip away from one another. Galaxy clusters thin. Superclusters dissolve into isolated islands. Each island retains its internal structure, but loses contact with the rest. This is not destruction. It is segregation. Dark energy does not tear galaxies apart. It separates them gently, persistently, until influence fades. The universe does not die in fire or collapse. It drifts. This drifting future carries a profound implication for knowledge. Observers living billions of years from now will inherit a radically impoverished sky. Most galaxies visible today will be gone from view. The cosmic microwave background, the faint afterglow of the early universe, will be stretched beyond detectability. The evidence for expansion itself may vanish. Future observers may see a universe that appears static, empty, and small, not because the universe changed its nature, but because dark energy hid its history. This is the cruel elegance of acceleration. It erases evidence without erasing existence. It rewrites the observable universe, not by removing content, but by removing access. Dark energy, therefore, acts as a kind of cosmic censor, not intentional, not malicious, but effective. It determines which regions remain in causal contact and which drift into permanent silence. What lies beyond those horizons still exists. Stars still burn, galaxies still evolve, but those processes unfold without ever intersecting your reality. They become part of a universe you cannot witness. This is where isolation becomes existential. It is tempting to imagine cosmic loneliness as a psychological state, a feeling humans project onto the sky. Dark energy makes it physical. It enforces separation at the level of space-time, even if the universe were teeming with life. Acceleration could ensure that most civilizations remain forever unknown to one another. Silence becomes structural. The most unsettling aspect is that dark energy does not seem to weaken with time. As matter thins and radiation fades, dark energy remains. Its influence grows relative to everything else. The universe's future is not one of reconnection. It is one of increasing separation. This does not mean despair. It means clarity. Understanding dark energy reframes humanity's moment in cosmic history. You live during an era when the universe is still richly connected, when distant galaxies are still visible, when the relic light of the early universe can still be studied. This window is not guaranteed to remain open. The present is privileged not because it is central, but because it is accessible. Dark energy reminds you that the universe is not obligated to preserve its own legibility. It does not archive itself for future observers. Knowledge must be gathered when it is available, or it may never be gathered at all. This realization does not diminish the value of cosmology, it heightens it. Every observation becomes a rescue of information from an expanding void. Every measurement becomes an act of defiance against isolation. Dark energy is not merely a parameter in equations. It is the reason the universe is becoming less knowable with time. It is the engine driving reality toward solitude, and yet, within that solitude, meaning persists. Understanding the mechanism does not undo its consequences, but it gives them shape. It allows you to see isolation not as abandonment, but as an outcome of structure. The universe is not pushing you away. It is simply expanding indifferently, consistently, and without concern for who is watching. Beyond the horizon is not darkness. It is silence without absence. When you imagine what lies past the limits of observation, the mind reaches for drama, exotic beings, unfamiliar laws, radical departures from what is known. But the first and most honest answer is quieter. Beyond the horizon may exist more of the same, more space, more matter, more history unfolding without witnesses. The horizon does not mark a change in reality. It marks a change in access. This distinction matters because it strips mystery of spectacle and replaces it with restraint. The universe beyond your reach is not obligated to be strange. It is obligated only to be unreachable. What exists there may follow the same physical laws, assemble into similar structures, and evolve through familiar processes. The difference is not nature. The difference is contact. Consider how horizons form. They are not walls erected at some special location. They are outcomes of timing and geometry. Light emitted too far away, too late, or under unfavorable expansion never arrives. Regions beyond the horizon are not hidden. They are simply excluded from interaction. This exclusion does not imply emptiness. In fact, emptiness would be the simpler outcome. It would require less explanation. A universe that stops where observation stops would be tidy. Reality, instead, offers continuity without access. Beyond the horizon, galaxies may cluster into filaments and walls just as they do here. Voids may yawn between them. Stars may ignite and die. Heavy elements may accumulate. Planets may form. None of this contradicts what is known. None of it requires speculation beyond established physics. What changes is confirmation. You cannot sample those regions. You cannot test whether they mirror the structures you observe. You infer by extension, not by evidence. This inference is reasonable, but it is not provable. The horizon draws a line between what can be tested and what must remain hypothetical. This is not a failure of imagination. It is a constraint on certainty. The temptation is to fill the unseen with extraordinary possibilities. But cosmology teaches caution. Extraordinary claims require extraordinary access, and access is precisely what is missing. The most responsible stance is not to invent, but to extrapolate conservatively, aware that extrapolation itself is an assumption. There is a deeper discomfort here. If regions beyond the horizon are similar to ours, then the universe is far larger than what you can ever observe, potentially infinite, or finite but vast beyond calculation. In either case, the observable universe becomes a sample, not a totality, and samples can mislead. What you observe may be typical, or it may not. Without access to the whole, you cannot know. The universe you see could be average, rare, or exceptional. Horizons deny you the comparative context needed to decide. This uncertainty seeps into fundamental questions. Is the distribution of matter uniform beyond the observable region? Do the same initial conditions repeat? Are the large-scale properties you measure representative? You can build models that assume yes. You can test consistency within the observable domain. But the horizon guarantees that some answers remain provisional. The universe beyond the horizon is therefore not a canvas for speculation. It is a mirror held at a distance. It reflects your assumptions back at you, asking how much you trust them when verification is impossible. This does not paralyze science. It disciplines it. Within the observable universe, you demand evidence. Beyond it, you label inference as inference. The line is clear. What lies beyond is not unknowable in principle, but untestable in practice. The difference is subtle but essential. There is also the matter of time. Horizons are not fixed. Regions now beyond reach were once closer. Their past light may still be arriving. You can observe their earlier states, even if their present and future remain inaccessible. This creates a strange asymmetry. You may know something about a region's history without ever knowing what it becomes. Knowledge without continuity. This asymmetry reinforces a sobering truth. The universe does not grant omniscience. It grants glimpses. You piece together a story from fragments that survived expansion. Beyond that, the narrative continues without you. This realization can feel diminishing, but it can also feel grounding. It places limits on speculation and anchors curiosity to what can be known responsibly. It invites a kind of intellectual humility that is rare in discussions of cosmic scale. Beyond the horizon, there is no guarantee of revelation, no promise that patience will be rewarded. There is only the acknowledgement that existence does not require an audience, and yet, this does not render the unseen meaningless. On the contrary, it sharpens the meaning of what is seen. If access is limited, then observation becomes valuable. If contact is fragile, then knowledge is precious. The universe beyond the horizon reminds you that reality is larger than experience, and that experience is shaped by position, timing, and geometry. You are not excluded by design. You are included by circumstance. What may exist beyond the horizon is not a question to be answered definitively. It is a boundary to be respected. The most honest response is not certainty, but clarity about what certainty requires. There may be more galaxies than you can count, more structure than you can map, more history than you can reconstruct. Or there may be repetition, simplicity, and uniformity extending far beyond sight. You do not know, and you cannot know. This is not a defeat. It is a description of the universe's terms. Beyond the horizon lies continuation without confirmation, existence without evidence, reality without relationship. The universe does not hide this from you. It shows you the limit plainly, through light that never arrives. And in accepting that limit, you learn something profound, not about what lies beyond, but about what it means to know anything at all. Silence is often mistaken for emptiness. When you listen and hear nothing, the instinct is to assume there is nothing to hear. In the cosmos, that instinct can be misleading. A universe can be crowded and still remain quiet, not because no one is speaking, but because connection has failed. The silence of the sky does not automatically imply solitude. Civilizations, if they arise elsewhere, are bound by the same constraints that bind you. They are limited by the speed of light, shaped by the expansion of space, and confined to their own causal neighborhoods. Even if intelligence were common, even if technology flourished across countless worlds, contact would not be guaranteed. Distance alone is not the barrier. Timing is. Every civilization exists within a window. It emerges, develops, and either persists or disappears over a finite span. That span must overlap with another civilization's window and lie within a region of causal access. Miss either condition, and contact never occurs. This is not a pessimistic scenario. It is a logistical one. Imagine two islands separated by an ocean that grows wider every year. Both islands host civilizations. Both develop communication. Both broadcast signals into the surrounding darkness. Yet the ocean expands faster than those signals can travel. The civilizations are not alone. They are isolated. Cosmic expansion plays the role of that ocean. Signals do not simply travel outward. They must fight against the stretching of space. Over large enough distances, even powerful transmissions lose coherence. Wavelengths lengthen, energy dissipates, messages blur into background noise. What arrives, if anything arrives at all, may no longer be recognizable as intentional. This means silence can be an artifact of physics, not absence. It also means that searching for contact is not just about looking outward, it is about looking at the right time. A signal sent millions of years ago may still be on its way. A signal sent tomorrow may never arrive. Two civilizations can exist simultaneously and still remain forever unaware of one another. This temporal misalignment is rarely emphasized. Popular imagination focuses on distance and technology. It imagines powerful transmitters bridging vast gaps. But technology cannot outrun geometry. No invention defeats expansion. The universe does not reward ambition with access. It rewards proximity and timing. This reframes one of humanity's most persistent questions. Instead of asking, "Why hasn't anyone contacted us?" a more accurate question emerges. Under what conditions would contact even be possible? Those conditions are restrictive. First, civilizations must arise within a limited spatial radius, close enough that light can travel between them, before expansion overwhelms the journey. Second, their technological phases must overlap in time. Third, their methods of communication must be compatible. And finally, their signals must survive cosmic noise, redshift, and dilution. Remove any one condition, and silence results. The result is a universe where civilizations may be plentiful, but partitioned. Each inhabits its own bubble of influence, shaped by local structure and expansion. Within those bubbles, interaction may be rich. Between them, nothing passes. This is not a tragedy written into the universe. It is a consequence of scale. On Earth, isolation feels temporary. Oceans can be crossed. Signals can be relayed. Time differences can be managed. In the cosmos, isolation can be permanent. There is no global network, no shared channel, no synchronization. The universe does not coordinate its inhabitants. This perspective removes the emotional weight often attached to cosmic silence. Silence does not mock intelligence. It does not diminish curiosity. It simply reflects the reality that the universe is not designed for conversation across extreme distances. Even if messages were exchanged, they would arrive transformed. A reply might take millions of years. A dialogue would not feel like dialogue. It would feel like archaeology interpreting artifacts from a past that no longer exists. This challenges the way contact is imagined. The expectation of real-time exchange is a projection of human scale. At cosmic scale, communication becomes historical rather than conversational. Civilizations may know that others exist without ever interacting. They may infer presence through physics, statistics, or theory. But inference is not contact. Knowledge without relationship does not erase silence. There is also the matter of perspective. Each civilization sees its own sky, shaped by its own horizons. What is accessible to one may be inaccessible to another. What appears empty from one vantage point may be densely populated from another. Reality fragments by location. This fragmentation suggests that the universe does not host a single, shared experience of existence. It hosts many local experiences, overlapping imperfectly or not at all. The idea of a universally connected cosmos is comforting, but it is not supported by the structure of space-time. Isolation, then, is not a failure of effort. It is a property of geometry. This does not render the search for life meaningless. It gives it context. When you search for signals, you are not just listening for neighbors. You are probing the limits of causal overlap. Every silence refines your understanding of what is possible. A silent cosmos can still be a populated one. Crowding does not guarantee contact. Presence does not guarantee awareness. Existence does not require recognition. Understanding this shifts the emotional tone of the question. The universe is not ignoring you. It is not withholding company. It is simply vast beyond the scale where connection is easy. In that vastness, civilizations may rise and fall, learn and wonder, never knowing that others once did the same beyond their horizon. Their stories unfold independently, complete without witnesses. This realization can feel lonely, but it can also feel liberating. Meaning does not require an audience. Intelligence does not require acknowledgement. Curiosity does not need confirmation. You are not diminished by cosmic silence. You are contextualized by it. The universe may be crowded with thought, invention, and reflection, each confined to its own island of causality. Silence does not deny that richness. It preserves it in parallel. In accepting this, the question of contact softens. The absence of messages stops being a verdict. It becomes a reminder of scale. The cosmos does not promise conversation. It offers existence vast, distributed, and quietly sufficient on its own terms. An unknowable universe does not diminish you. It defines you. When the limits of observation become clear, when horizons harden into facts rather than challenges, the temptation is to feel excluded, as if reality were withholding something owed. But the universe does not owe explanation. It offers context. And within that context, meaning emerges not from total access, but from position. You exist inside a fragment of reality that can still speak to you. That fact alone is extraordinary. For most of human history, the sky was a backdrop. It carried symbols, stories, and cycles, but not distance. The stars were fixed lights, eternal and nearby in spirit. Modern cosmology replaced that intimacy with scale, then replaced scale with limits. What remains is not emptiness, but perspective. You are not meant to know everything. You are meant to know where you stand. The unknowable universe strips away a comforting illusion that curiosity, given enough time, guarantees completion. It replaces it with something harder and more honest. Knowledge is local. Access is conditional. Understanding is earned within boundaries that cannot be negotiated. This does not reduce the value of inquiry. It clarifies it. Science is often portrayed as a march toward omniscience, a steady erosion of mystery. In reality, science refines mystery. It separates the unknown into what is temporarily hidden and what is structurally inaccessible. The latter category does not signal failure. It signals maturity. To recognize a limit is to understand something deeply. Living in an unknowable universe forces humility into thought. It discourages grand claims about totality. It tempers speculation with discipline. It asks you to distinguish between what is inferred responsibly and what is imagined freely. This discipline is not restrictive. It is liberating. It frees you from the need to resolve every question. It allows wonder to persist without demanding closure. Meaning, then, does not come from mastering the cosmos. It comes from engaging it honestly. You are part of a universe that will never fully reveal itself. and yet it reveals enough to inspire awe, curiosity, and care. That balance is not accidental. It is the result of physics meeting perspective, of laws that permit complexity without guaranteeing comprehension. Within those laws, human existence takes on a particular weight. You are not central. You are not privileged by position, but you are privileged by timing. You live during an era when the universe is still legible, when distant galaxies still announce their presence, when the afterglow of the early universe can still be detected, when cosmic history has not yet faded beyond reach. This is not a reason for urgency. It is a reason for attentiveness. The unknowable universe does not ask you to conquer. It asks you to witness, to observe carefully, to measure honestly, to record faithfully. What you gather now may not be recoverable later, not because of catastrophe, but because of expansion. In this sense, science becomes stewardship. Knowledge is not hoarded for power. It is preserved against erasure. There is also a moral implication. If reality does not guarantee full disclosure, then certainty becomes suspect. Dogma loses its footing. Intellectual humility becomes a virtue, not a concession. The unknown is not a threat to be eliminated, but a boundary to be respected. This humility does not weaken meaning, it grounds it. Human stories have always grappled with limits, mortality, uncertainty, finitude. The unknowable universe extends that theme to the cosmic scale. It reminds you that existence is not validated by comprehension. Things do not need to be understood to be real. They do not need to be seen to matter. Your life unfolds within a vast structure that does not revolve around awareness. And yet, awareness exists. Consciousness arises. Questions form. Reflection occurs. That alone is remarkable. In an unknowable universe, meaning is not handed down from above. It is constructed locally. It arises from relationships, from curiosity, from the act of looking outward. Even when you know the view will always be partial, you do not need the whole to find purpose. You need connection to others, to knowledge, to the fragment of reality that intersects your experience. This is not resignation. It is alignment. The universe is not indifferent in a personal sense. It is indifferent in a structural one. It does not tailor itself to understanding. It allows understanding where conditions permit. That allowance is not guaranteed. It is contingent. Recognizing this makes the act of knowing feel fragile and precious. Every measurement, every theory, every insight exists within a narrowing window of access. What you learn now is not merely interesting, it is timely, and yet, the unknowable universe does not render human effort insignificant. On the contrary, it elevates it. To seek understanding in a reality that does not promise completeness is an act of courage. To value truth without demanding finality is a mark of intellectual maturity. You are not small because the universe is large. You are small because you are finite, and finitude is not a flaw. It is a condition that gives shape to meaning. An infinite, fully knowable universe would be sterile. It would leave no room for discovery, no space for wonder, no reason to listen carefully. Limits create texture. Boundaries create focus. The unknowable universe teaches restraint. It encourages reverence over ownership. It reminds you that existence is not a puzzle to be solved, but a context to be inhabited. You stand inside a bubble of visibility, surrounded by more reality than you can ever confirm. That fact does not diminish your place. It defines it. You are a witness, not a ruler, a participant, not a master, a thinker inside a cosmos that will always exceed thought. And in that excess, in what remains forever beyond reach, meaning does not disappear. It deepens.